Hello everyone, this is Mr. Fez. I am an actual math teacher, I promise. I want to start by asking you these two questions. Here's a triangle. Which side is the longest? Which side is the shortest? And explain, tell me why. If I go too fast throughout this video, feel free to pause the video, watch it in slow motion, whatever you have to do. I usually don't move too fast. If anything, I probably move too slow. So let's answer these. I'm hoping you know the answer to the first question at least. You should know through working with the Pythagorean theorem that C, the hypotenuse, is the longest side. And the reason is that C is across from the largest angle, the 90-degree angle. Okay. The shortest side length would then be across from the shortest angle, or smallest angle, the 44 degrees. So across from the 44, head out away from that, and I hit B. So it's for that reason that B is the shortest side. Okay, so the larger an angle is, here's an obtuse angle. It opens up a ton, so if I connect these to make a triangle, I'll attempt to draw a straight line, not very good. That's a much longer side than if I draw an acute angle and connect that. Right, so the bigger the angle, the bigger the side across from it. That's true of within any triangle, not just a right triangle. We're going to continue to only look at right triangles today. Okay, here's another situation where I don't have any side lengths, I just have A, B, C, and I want to know what is the ratio of B to A. Now, ratios can be fractions, and they're just comparing two numbers. I like to write them as fractions because I'm already familiar with working with fractions, so I went ahead and already wrote this ratio as a fraction. What they want for the answer here is a number. All right. So just like last time, C is the hypotenuse, C is the largest side here. However, A and B are both across from 45-degree angles. So if these two sides are across from equal angles, they're going to be equal side lengths. So B and A are the same thing. I don't know what they are, but I do know that they're the same length. So I know that this answer is 1. Okay, a big 1. All right, it's another situation. I don't know if these diagrams that I drew are drawn to scale. Probably not. I labeled this angle as 36.87 degrees. Okay. In this case, I know that the ratio of B to A for this triangle, even though I don't know what they are, is about 0.75. Okay. And I know that because of this angle here. I don't actually just know that offhand, I calculated it. But there's a function actually on your calculator called tangent, abbreviated TAN, that relates B to A in this way. So if you were to type or press the tangent button, TAN, and then type in 36.87, enter, you'd get about 0.75. It'd be a little bigger, I think. It's not exact. But it's kind of nice that if we know the angle of a triangle right here, that we could figure out the ratio of these sides. Because, for example, if I tell you A is 4, okay, if I just gave you this equation right here, you know what B is going to be, right? You know 3 over 4 is 0.75. So you'd say, well, if A is 4, and I know the ratio of those two sides is equal to 0.75, then B has to be 3. Okay. If this angle over here was something other than 36.7, then this 0.75 would change. And that's what we're going to talk about in this video, and when I arrive on Thursday, are about that function tangent and two other functions that relate sides of a triangle when you know the angles. Okay? So let's define these three functions that deal with right triangles: sine, cosine, and tangent. Okay? So here's what these functions do, and we're going to use our calculator most of the time to find answers for these when we find missing lengths in triangles. These functions are functions that relate an angle measure to the ratio of certain sides of a right triangle. So just like Pythagorean theorem, these functions only apply to right triangles. So here's how you define them. Right? This symbol inside the triangle right here, it's I think Greek letter, pronounced theta, Theta. It's just a symbol used to denote an angle a lot. Right? So we just talked about tangent. And tangent of this angle theta relates to the following two sides. The opposite side, so the side opposite, if I start my cursor here and then move it out away, it crosses the opposite side. Opposite over the adjacent side. So we already know the hypotenuse is this. So the hypotenuse, I guess, is technically adjacent, but since hypotenuse is kind of, unique over here, we call this other side that's next to it, next to theta, the adjacent side. Okay, let's jump back up to sine, and I'll tell you how to define that one. So these are the abbreviations. Okay. So on your calculator, you'll see it SIN, COS, and TAN. Sine relates the opposite side of theta to the hypotenuse. Okay. By the way, if I said theta was over here, then this would be the adjacent side. Okay. So these functions are also referring to this diagram that I have. Cosine of theta is the adjacent side over the hypotenuse. And one of the ways to memorize all this, there's an acronym for it. So sine, it's on the next page, but I'm going to type it out here so you can see everything. Sine is opposite over hypotenuse. Cosine, I'm saying it as I type, is adjacent over hypotenuse. Tangent is opposite over adjacent. SOHCAHTOA. That's how we say that. SOHCAHTOA. Sine, cosine, tangent. Okay, so you don't have to write all this out, but just to remind you of how it starts and kind of the pattern. So that's helpful just as far as memorizing the things. Okay. So for this diagram, if I ask you, what is the ratio sine of theta, right, you'll have to go back and check, okay, sine of theta is equal to the ratio of the opposite side over the hypotenuse side. So the opposite side is 12. The hypotenuse is 13. So you can write 12 over 13. You could divide 12 by 13 on your calculator and get the decimal if you wanted to, but that's fine. I'll just leave them as fractions. For this triangle, same process, just it's a larger triangle. So opposite 16 over hypotenuse 20. Should you simplify? I say the answer to that question is always yes when students ask me. I say that same answer when they ask me, do we need to show work? This is what, 4 over 5? Okay, same triangles, but new functions. Cosine of theta. Cosine is the adjacent over hypotenuse, so the adjacent side here, where theta is labeled, is important. The adjacent side is 5 over the hypotenuse, which is 13. Tangent is opposite over adjacent. So 16 over 12 or 4 over 3. Okay, so we can use these functions on our calculator to find missing sides when we're given angles. So with Pythagorean theorem, we needed 2 out of the 3 sides, and then we could find the third. With these, what are called trigonomic functions, we really only need one side and one angle, and then we could find anything else we need, really. The other 2 sides of the triangles and the remaining angle. Okay, I'm going to review this with you. If you don't understand some of this, it's okay. We'll review some of this, and then we'll get into the problems where we solve for missing pieces and stuff like that, and we'll use our calculator for all those. Okay. I hope this was not torture. If it was, you're gonna hate Thursday. Looking forward to it. Thank you, everybody.